Hello students, now I am going to discuss Cambridge A-Level Chemistry May-June 2024 paper 22. May-June 2024 paper 22. Let's move. Number 1. Complete table using relevant information from the periodic table. Magnesium ion, aluminum ion. So nucleon number, magnesium nucleon number means mass number 24. Aluminum mass number, nucleon number 27. Number of proton magnesium is 12. Number of proton in aluminum ion is 13, means atomic number. Now number of electrons, magnesium proton number 12 plus 2 means 2 electron less, so 12 minus 2, 10 electron. Aluminum ion 13 minus 3, 10 electrons. 10 electron. B. State and explain the difference in the ionic radius of aluminum ion and magnesium ion. And you know, aluminum ion is smaller than magnesium ion because magnesium ion aluminum ion, this is the across the period metallic radius, for metal ionic radius decreases. So aluminum ion is smaller than magnesium ion. This is because magnesium has 2 electron shell, aluminum ion has also 2 electron shell, so shielding is same as shell number same. But aluminum ion has 13 proton in nucleus and magnesium ion has 12 proton. So aluminum ion has greater nuclear charge, so there is greater attraction between electrons and nucleus. That's why aluminum ion is smaller than magnesium. C. Draw a label diagram to show the structure and bonding in sodium. Sodium is a metal, so in sodium there is metallic bonding. Now this is positive ion, these are positive ion, sodium ion. E means electron, so this is the positive metal ion and this is the delocalized electrons. And metallic, the attraction between positive metal ion and C of delocalized electron is known as metallic bonding. So this is the label diagram in sodium metal. Next, number D. Figure shows the variation in the melting point of period 3 elements in their standard states at room temperature and pressure. So this is the y-axis melting point, x-axis elements sodium, magnesium, aluminum, silicon, phosphorus, sulfur and chlorine. So shows the variation in the melting point of some period 3 elements in their standard state at room temperature and pressure. So this is magnesium, this is silicon highest, then silicon to phosphorus, they are non-metal and they are simple molecule. So phosphorus, sulfur, chlorine, they are simple molecular structure, but sulfur, phosphorus has 60 electrons, sulfur exists as H8, so it has 16 times 8, 128 electron, chlorine 34 electrons. So in among phosphorus, sulfur, chlorine, sulfur has more boiling point than phosphorus and chlorine. Explain why silicon has high melting point. And silicon has giant covalent structure, so large amount of energy is needed to break these bonds. You know, silicon is a giant covalent, there are many covalent bonds in it. For melting many covalent bonds, more energy is needed, that's why silicon has high melting point. Now number 2, complete figure 1.1 to show the variation in the melting point of elements phosphorus, sulfur and chlorine. And you see sulfur, this is the sulfur has 128 electrons, phosphorus has 60 electrons, chlorine has 34 electrons. So sulfur has highest melting point than phosphorus and chlorine. E, two period 3 elements react with an excess of oxygen at room temperature. Complete the table 1.2. Period 3 elements, sodium, metal, solid and sulfur also solid gas. Sulfur is solid but state of oxide at room temperature and pressure. So sodium reacts with oxygen to form sodium oxide. Sodium oxide is a solid, and sulfur reacts with oxygen to produce sulfur dioxide. Sulfur dioxide is gas, sodium oxide is solid. Now approximate pH of solution made when oxides is added to water. So sodium oxide reacts with water to produce sodium hydroxide. This is strong alkali. So pH will be 10 to 14. I write here 12, or you can write 13 or 14, you will get marks. Sulfur dioxide reacts with water to produce sulfuric acid. So sulfuric acid is strong acid, its pH will be 0 to 4, strong acid. So I write here 2, you can write also 3, you will get mark. Next, the solutions made in column 3, this is of table 2, are mixed together. Name the type of reaction that occurs. This is the neutralization reaction or acid base reaction, because this is sodium hydroxide and this is sulfuric acid. When sodium hydroxide reacts with sulfuric acid, this is neutralization reaction or acid base reaction. Number 3, write an equation to describe the reaction between phosphorus 5 oxide and excess water. Phosphorus 5 oxide reacts with water to produce phosphoric acid. Phosphorus pentoxide reacts with water to produce phosphoric acid. Phosphorus oxide is a non-metal oxide. Non-metal oxide is a acidic oxide. Acidic oxide reacts with water to produce acid. F. Aluminium hydroxide is amphoteric. Explain what is meant by amphoteric. Amphoteric means reacts with both acid and base. Amphoteric hydroxide, amphoteric oxide reacts with both acid and alkali, or you can write shows both acidic and basic properties, basic behavior. Next, write an equation to describe the reaction that occurs when aluminum hydroxide reacts with sodium hydroxide. Aluminum hydroxide reacts with alkali to form complex salt sodium aluminate NaAlOS4. Sodium aluminate. Question number 2. Separate samples of sodium carbonate and sodium hydrogen carbonate react with aqueous hydrochloric acid to produce the same products as shown in the table. Reaction 1. Sodium carbonate reacts with hydrochloric acid to produce sodium chloride, water and carbon dioxide. Enthalpy change del H1. Reaction 2. Sodium hydrogen carbonate reacts with hydrochloric acid to produce same product sodium chloride, salt, water, carbon dioxide. Del H2 change in enthalpy plus 27.2 kilojoule per mole. Now A. Complete the reaction pathway diagram in figure 2.1 for reaction 2. And you see reaction 2 is delta is positive, so reaction 2 is endothermic reaction. This is the reactants, this is products. You know, in endothermic reaction product has more energy than the reactants. Reactant has less energy, product has more energy. Product is the above than reactant in endothermic reaction. So this is the reactants given. This reaction will go this pathway and this is the products. Product has more energy than the reactants. So product is sodium chloride, water and carbon dioxide. This is the product. And label the diagram to show the enthalpy change del H2 and activation energy EA. This is the EA. Activation energy means the energy difference between reactant and peak of the curve. This from this to this energy is known as activation energy. The energy difference between reactant and peak of the curve is known as activation energy. Next, B. The value of del H1 is determined by experiment using the following method. 50 centimeter cube, volume is 50 centimeter cube, 2 mole per dm cube hydrochloric acid. Hydrochloric acid volume is given, concentration is given, is added to a polystyrene cup. The initial temperature of the acid is recorded as 19.6. Initial temperature 19.6. And sodium carbonate mole 0.0400 mole of sodium carbonate is added and the mixture is stirred. All the solid sodium carbonate dissolves and the colorless solution is produced. The maximum temperature recorded during this reaction is 26.2 degrees centigrade. So here what is given? Volume of hydrochloric acid and concentration is given. initial temperature is given and this is the final temperature also given. Sodium carbonate mole is given. So you are asking, describe one other observation that shows that the reaction is complete. That means how you can understand the reaction is complete. Answer will be no more fizzing or no more bubbles, or fizzing stops, or effervescence stop, as hydrochloric acid reacts with sodium carbonate. So you know, any carbonate reacts with acid to produce salt plus carbon dioxide plus water. As carbon dioxide is formed, so fizzing occurs. When reaction will be complete, no more fizzing will be seen, mean fizzing stop. Next, number 2, calculate the value of del H1. Assume the specific heat capacity of the reaction mixture is the same as for water, means 4.18, and no heat is lost to the surrounding. So you're working. So first of all, energy transferred Q or E equal mc del T. M is the mass of solution, C is the specific heat capacity, del T is the change in temperature. So m 50 by 1000, 50 gram. So divide by 1000, this is kilogram is converted to kilogram. 50 is given. Volume of solution is 50 centimeter cube, means 50 centimeter cube means 50 gram. 1 centimeter cube equal 1 gram. So 50 divided by 1000 times C 4.18, and you know this given 26.2 final temperature, 19.6 was initial temperature. So del T will be final temperature minus initial temperature. So if you calculate, you get 1379.4 kilojoule. Now you are asking, calculate the del H1. Enthalpy change, del H1 means reaction 1. You see, when sodium carbonate reacts with hydrochloric acid, sodium chloride, water plus carbon dioxide is formed. Calculate the del H1, enthalpy change of the reaction. Now you see, energy transferred Q equal 1379.4 kilojoule. So del H1 enthalpy change will be change in energy divided by number of mole. I mean enthalpy change will be energy transferred divided by number of mole. Number of mole 0.04 mole is given. So you will get 34.485 kilojoule per mole, or you can write 34.5. Why minus sign? As you know, temperature is increasing, so this reaction is exothermic reaction. For exothermic reaction, delta H value is negative. That's why del H1 is minus 30.4 kilojoule per mole. Next, thermal decomposition occurs when sodium hydrogen carbonate is heated. Reaction 3, sodium hydrogen carbonate breakdown to form sodium carbonate, water and carbon dioxide. Calculate the enthalpy change for reaction 3. This means this reaction 3 using the data in table 2.1 and the value of del S1 calculated in B2. So you know, this is the reaction 3 and this is the reaction 1. This is the reaction 2. Reaction 1 and 2 is given here. Reaction 1, reaction 2. So from reaction 2 and 1, how you will get reaction 3? If you multiply by reaction 2 by 2, then subtract 1, reaction 1, you will get this reaction 3. That means enthalpy of reaction 3 will be 2 times del H2, means enthalpy of reaction 2 minus del H1. This R2, reaction 2 times 2 minus R reaction 1, you will get enthalpy change of reaction 3. So 2 times del H2 value 27.2 is given, and del H1 you calculate here 35.4. So if you calculate, you will get plus 88.9 kilojoule per mole. This is the enthalpy of the reaction for reaction 3. This is the enthalpy of the reaction 3. See, Z is a salt that contains a period 4 element from group 2. When Z is heated, brown gas is formed. Identify the formula of Z and use it to write an equation for this reaction. This is group 2, calcium nitrate, period 4, you will get, this will be calcium nitrate, metal will be calcium. If you give heat calcium nitrate, group 2 nitrate, it will form group 2 oxide plus brown fumes of nitrogen dioxide plus oxygen. So that's why calcium carbonate decompose breakdown to form calcium oxide, brown fumes of nitrogen dioxide plus oxygen. Question number 3a. Describe what is meant by dynamic equilibrium. Dynamic equilibrium means rate of forward reaction and rate of backward reaction are equal and concentration of reactant and product remain constant. So what is dynamic equilibrium? Dynamic equilibrium means rate of forward reaction and rate of backward reaction or reverse reaction are equal and concentration of reactant and product remain constant. B. Reaction 4, this is the reaction 4, iron 3 ion reacts with thiocyanate ion to form iron thiocyanate. Iron 3 is yellow, this is colorless, this is red. So if equilibrium move from left to right, we would see more red color, and if equilibrium move from right to left, we will see more yellow color. So an equilibrium mixture contains iron 3 ion, thiocyanate ion and iron thiocyanate aqueous. A few colorless crystals of soluble potassium thiocyanate are added. The mixture is then left until it reaches equilibrium again. The temperature of both equilibrium mixture is the same. Number 1. Deduce the changes that occur, if any, in the equilibrium mixture after potassium thiocyanate is added compared to the original equilibrium mixture. So first, change in appearance. So if you add, you see potassium thiocyanate, this means reactant concentration increases, thiocyanate HCN minus concentration increases. So equilibrium will move from left to right. We would see appearance more red color. So answer will be more red. And second, change in relative concentration of iron 3 ion. So as thiocyanate is added, extra thiocyanate reacts with iron 3 ion to form product. So concentration of iron 3 ion will be decreases. As equilibrium move from left to right when thiocyanate is added, so concentration of iron 3 decreases. Change in relative concentration of iron 3 decreases. The next, change in value of the equilibrium constant Kc. Kc remain constant. So Kc has effect only temperature. There is no effect on the concentration. There is no effect on Kc for the concentration. So change in value of the equilibrium constant, it will remain constant, or you can write none. Next, five times 10 to the power 5 mole of iron 3 ion mole is given and thiocyanate ion mole is given, are added together and allowed to reach equilibrium. The total volume of the mixture is 25 centimeter cube. So iron 3 ion mole is given, thiocyanate mole is given, and volume is given 25 centimeter cube. At equilibrium, the concentration of iron thiocyanate is 4.23 10 to the power minus 4 mole per dm cube. Equilibrium iron thiocyanate concentration is given. So calculate the equilibrium constant Kc for reaction 4. Now you see iron 3 ion thiocyanate, iron thiocyanate. So concentration at initial, number of mole divided by volume, 25 divided by 1000, so it is converted to dm cube. You get moles of iron 3 ion this, and moles of thiocyanate, number of mole, n equals Cv. So C will be n by V, number of mole divided by volume. 25 divided by 1000, so 1000 go off. You will get mole of thiocyanate ion 0.0020, and initial there is no product, so number of mole 0. Now concentration at equilibrium will be, and you see the concentration of iron thiocyanate is given. This is the product, 4.23 times 10 to the power minus 4, that means 0.300000423 mole per dm cube. This is the product. So concentration of reactant will be initial mole divided by this product will move from the reactant. So product mole, product concentration have to subtract from the reactant. This product is formed from reactant. So concentration at equilibrium will be initial minus that that amount react. So you will get concentration at equilibrium iron 3 ion this, and also concentration of thiocyanate ion initial concentration minus that reacted, you have to subtract, so you will get 0.001577 mole. This product is formed from the reactant. So concentration, to calculate concentration of reactant, product concentration have to subtract. That's why this minus this minus this. So now you get the concentration at equilibrium. Then Kc equal producter concentration divided by reactant concentration. If you keep value, you will get 170 mole inverse dm cube. See, determine the full electronic configuration of iron 3 ion. You know, iron is 26. Iron has 26 electrons, so iron 3 plus has 23 electrons. 1s2, 2s2, 2p6, 3s2, 3p6, 3d5. 3 electron lost, 2 electron lost from 4s2, and 1 electron is lost from 3d6. So Fe3 plus electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p6, 3d5. Number D, thiocyanate ion is colorless. Complete the dot and cross diagram to show the arrangement of outer electrons in thiocyanate ion. So thiocyanate ion is S, C, triple bond, N. So triple bond means 6 electron. 3 electron gives carbon, 6 electron, and 3 electron gives nitrogen. Nitrogen is a group 5 elements. So if 3 electron gives triple bond, 2 electron remain as lone pair. Now sulfur has 6 electron in its outer shell, 2, 4, 6. Then carbon 3 remaining 1, as it is minus, so 1 electron is more. Or you can show here 3 electron carbon, 3 electron nitrogen, triple bond, carbon negative, sulfur. So nitrogen remaining 2 electron as lone pair. Carbon gives 3 electron here, 1 electron is here, and minus 1 is, means 1 electron more, so 2 electron. And this is dative bond, dative covalent bond. Sulfur group 6 elements, so outer shell has 6 electron, remaining 6 here. Number 4, this organic molecule exists as pair of stereoisomers. Draw the 3-dimensional structure of 2 stereoisomers of this molecule. R can be used to represent CH3 CH2 whole 5. So this molecule has 1 chiral carbon, so it will show optical isomer, 2 optical isomers. So this carbon, chiral carbon, this CH3 group above, 1 bromine, 1 hydrogen, and 1 CH3 CH2 whole 5, this molecule. Chiral carbon, 1 methyl group, 1 bromine atom, 1 hydrogen and 1 CH3 CH2 whole 5. So this carbon is attached to 4 different group. So this will show optical isomer, and this molecule mirror image, non-superimposable mirror image. So this is carbon, this CH3, this group you can see from left hand side, and this bromine right hand side. This molecule is optical isomers, as this molecule is non-superimposable on its mirror image. This molecule is non-superimposable on its mirror image. So this molecule show 2 optical isomers. And a sample of this organic molecule reacts with sodium hydroxide to make alcohol in an SN1 mechanism. So haloalkane to produce alcohol, this is SN1 reaction with sodium hydroxide, as this is a tertiary haloalkane. Halogen containing carbon is attached to alkyl group. So this is secondary haloalkane. This reaction occurs in SN1 mechanism. So complete figure 4.1 to show the mechanism for this reaction. Haloalkane with sodium hydroxide. You include charges, dipoles, lone pairs of electrons and curly arrows as appropriate. So you see SN1 mechanism, you know, bromine CBr bond. Bromine is more electronegative, so electron will move to the bromine atom. This become partially negative ion, delta minus partially negative. Carbon become delta plus. So as bromine takes electron, become bromide ion, and this positive carbonium ion is formed. First step, bromine takes electron, positive carbon is formed. SN1 mechanism occurs to a step. When positive carbonium ion is formed, nucleophile, I mean hydroxide ion, gives its lone pair electron to positive carbon to produce alcohol. This is SN1 mechanism. Next, see separate samples of this molecule, haloalkane, alcohol, and this is alkene, are tested with different reagent. Complete the table. If no reaction occurs, write cross in the box. So you see this is haloalkane, this is alcohol, and this is alkene. This here double bond alkene. So why alkene? This is CH double bond CH2 here. This is an alkene, it contains carbon-carbon double bond. So if you add bromine water or liquid bromine, bromine does not react with haloalkane, so no reaction. And if you add bromine water or liquid bromine, this alkene reacts orange to colorless. If you add bromine water or aqueous bromine in alkene, orange bromine solution turns to colorless. phosphorus pentachloride. So haloalkane does not react with phosphorus pentachloride, though this is already cross. And you know, this is alcohol group. Alcohol reacts with phosphorus pentachloride to produce haloalkane, phosphorus trichloride oxide, and steamy fumes of hydrogen chloride gas. So this alcohol reacts with phosphorus pentachloride to form steamy fumes of hydrogen chloride, and alkene does not react with phosphorus pentachloride, so this is cross. Now silver nitrate. So as aqueous silver nitrate, this bromide ion. So if you add aqueous silver nitrate, silver bromide, this is cream precipitate will form, or you can write off-white precipitate. Silver nitrate reacts with bromide ion to produce off-white precipitate or cream precipitate, and alcohol does not react with silver nitrate, and also alkene does not react with silver nitrate, so both are cross. Number D, this haloalkane is heated with D to produce three different molecules EFG. So this haloalkane to form alkane, EFG, both all are alkane. So elimination reaction occurs, and you know, number one, name the type of reaction. This reaction type is elimination reaction. Haloalkane reacts with ethanolic sodium hydroxide, or haloalkane reacts with sodium hydroxide dissolved in ethanol to form alkene. This reaction type, you know, elimination reaction. So number two, identify D. D means haloalkane reacts with sodium hydroxide in alcohol or sodium hydroxide in ethanol to produce alkene. E1, both sigma and pi bonds are present in molecule E. Molecule is this alkene. As a result of different types of hybridization of carbon atoms, complete this table to show number of carbon atoms with each type of hybridization, with type of hybridization in molecule E. That means what type of hybridization occurs, and you know, this is sp hybridization occurs when there are carbon-carbon triple bond. As molecule E has no any triple bond, so its number of carbon atoms that has hybridization sp hybridization is 0. No sp hybridization, as there is no triple bond, carbon-carbon triple bond. So no triple bond means there is no sp hybridization, and you know, sp2 hybridization occurs carbon-carbon double bond. So there are here two carbon, 1 2, that's why answer is 2. And sp3 hybridization occurs in carbon-carbon single bond. So how many carbon-carbon single bond? 1 2 3 4 5 6. So answer is 6. Now number 2, describe the essential feature of an unbranched hydrocarbon that caused its molecules to show stereoisomers. Explain how this feature leads to stereoisomerism. So presence of pi bond, that means molecules must have carbon-carbon double bond, and limited rotation of carbon-carbon double bond, and two different groups on every double bonded carbon, means there is restricted rotation to show unbranched hydrocarbon to cause stereoisomers, there is restricted rotation around carbon-carbon double bond, and every double bonded carbon contain mass two different groups. So two different groups on each double bonded carbon. This is the answer. There is restricted rotation around carbon-carbon double bond, and every double bonded carbon contain two different groups. That means molecules must have carbon-carbon double bond, and every double bonded carbon contains, if it contains CH3, this need different groups, say hydrogen. If this contains CH3, this contains different group hydrogen. So every double bonded carbon contain two different group. Hello, question number 5. Compound W has molecular formula C4H10O. It contains only one functional group. Number A. Table 5.1 shows two peaks with greatest M by E, mass by M by E means mass by charge values in the mass spectrum of W. M by 74, relative abundance 50, M by E 75, relative abundance is X. 1. Calculate the relative abundance X of the peak M by E equals 75 using the information from the table 5.1. And we know number of carbon atom equal 100 divided by 1.1 times abundance of M plus 1 ion peak divided by abundance of M plus ion. So here number of carbon atom is 4 equal 100 divided by 1.1. M plus 1 means 75 is X, and M plus ion is given 50. So if you calculate, you will get X equal 2.2%. So X equal 2.2. Now number 2, the mass spectrum of W also shows peak at M by E 29 and M by E 59. Suggest the molecular formula of these fragments, and you see M by E 29 W C4H10O, this is CH3 CHOH CH2 CH3. This is butanol. This is butanol C4 1 2 3 4 C4 3 4 5 6 7 10 H10 and 1 oxygen. So if it break down here CH3 CH2 plus, so here 2 carbon 24 plus 3 plus 2 5 hydrogen, it M by E value will be 29. So M by E 29, the ion will be CH3 CH2 plus. M by E 29, the ion will be CH3 CH2 plus. Now M by E59, this will be CH2 CHOH plus. That means it break down here. CH3, this ion will form at M by E value 59, CH3 CHOH CH2 plus, means butan to all. So CH3 CHOH CH2 CH3, butan to all. So if it break here, this ion will form positive ion. So C1 2 3 36, 12 times 3 36, 1 oxygen 16, and hydrogen 3 4 5 6 7. So if you sum 6 6 12 19, 3 4 5 59. So M by E value 59 will be CH3 CHOH OH CH2 plus. This will be CH3 CH2 CHOH plus. Now you see number B. A sample of WC4H10O is heated under reflux with excess acidified potassium dichromate until there is no further reaction. Only one organic product X is present in the mixture at the end of the reaction. Figure 5.1 shows the infrared spectra of W. You see this is A. It is an alcohol. OS peak, broad peak is given. So this table is given. If alcohol, hydroxyl group 3200 to 3650 wave number, there is a broad peak here. So A is the alcohol peak. Now the product 5.2 shows the infrared spectra of X. This is not sharp peak. This is a B is the carbonyl group peak. So you see carbonyl group peak shows between 1500 to 2000. This is carbonoxygen double bond carbonyl 1607 to 1740 wave number. So this is a carbonyl group peak. Now you are asking absorption A is shown in figure 5.1, B is shown 5.2. Complete the table 5.3. So absorption A, this is the OS bond and this is the hydroxy group or hydroxyl group, and spectra B is carbonoxygen double bond. This is carbonyl group. Number 2, use the information A and B to draw the structure of X in the box 5.3, and you see X is an alcohol. So alcohol, this is, and X you get carbonyl group peak. So this will be alcohol will be butan to all, secondary alcohol oxidized by acidified potassium dichromate to form butane 2-one. So X will be 2 butanone. 1, 2, 3, 4. X will be butane 2-one. So it will show a carbon oxygen carbonyl group peak, and this show an hydroxy group peak. I mean W is a secondary alcohol and X is a 2-butanone or butane 2-one. Now you see Y is a structural isomers of W. Both W and X produces colorless bubbles when sodium is added. Sodium reacts with alcohol to form hydrogen, and Y does not react when heated with acidified potassium dichromate. That means it is not primary alcohol, not secondary alcohol, not aldehyde. So as it reacts with sodium, so it is a alcohol. Now as it does not react with acidified potassium dichromate, that means this alcohol is not oxidized. You know, tertiary alcohol does not oxidize. And Y does not react when warmed with alkaline iodine. That means this will not show iodoform test. Iodoform test give alcohol only ethanol, and say all secondary alcohol all methyl ketone. So number 1, name the functional group present Y. Y functional group will be, this is the tertiary alcohol or 3-degree alcohol. Number 2, complete the equation to describe the reaction of W or Y with sodium. So alcohol, this is an alcohol, reacts with sodium to produce sodium alkoxide. As this is butanol, so sodium butoxide plus hydrogen gas will form. And number 3, draw the structure of Y. Y is a tertiary alcohol, C4H10O. So this is a second tertiary alcohol. This alcohol reacts with sodium to produce sodium butoxide plus hydrogen gas.